Okay, so today is 3/11/15. This is number 1 on your stoichiometry, limiting and excess practice. So who's got it balanced already? Okay. Emma, go. Okay, let me get that number in there. 3 ammonium nitrates and 3 sodium nitrates. Yep, that's it. That gets you balanced. So now we have a balanced chemical reaction to work from. And we're told that we start with 30 grams of ammonium nitrate and 50 grams of sodium phosphate, which is limiting, which is excess. What mass remains? First thing I would do in a problem like this is I would immediately scratch over here on the side all of the masses that I'm dealing with so that I've got them for reference. So I've got my ammonium nitrate, 2 nitrogen, 4 hydrogen, 3 oxygen. And I have my sodium phosphate, 3 sodiums, 1 phosphorus, 4 oxygens. We get a mass of 163.94 grams per mole. Okay, now what? What do I start with? It doesn't matter which given we start with, we just have to pick one. My habit is I just go with whatever's first. So I'm going to start off with 30 grams of ammonium nitrate. So I've got my 30 grams of ammonium nitrate in the first box. Because I'm starting with mass, I have to convert to moles, right? What units and what chemical go down below to cancel? Grams of ammonium nitrate. So I've got 1 mole of ammonium nitrate is equal to, and of course I figured this out already, 80.06 grams of ammonium nitrate. Now I'm in moles, so I'm ready to go to what? Mole ratio. So I know that I'm looking for the ratio between the number of moles of ammonium nitrate and the moles of sodium phosphate. What is my mole ratio here? 1 to 3, 3 to 1. We have 1 mole of sodium phosphate for every 3 moles of ammonium nitrate. So at this point, I'm ready to go back up from the valley of the moles, back to the highlands of mass. I've climbed down through moles. So what's my next box going to contain? Okay, so my final box is going to be a conversion back into grams of sodium phosphate. And I know, because I already figured it out, that 1 mole of sodium phosphate is 163.94 grams. So now you're ready to do some math. Who's got a raw number for me? Okay, so for our raw answer we get 20.4771414 grams of sodium phosphate. What does it mean? This is where your sentence comes in handy. So I'm going to go ahead and just write the sentence and then fill it in. Okay, so blank could react blank, but we have blank, so we will A, run out, or B, have some left. And number 1 comes from our given that we started our factor label with, 30.0 grams of ammonium nitrate. Could react, and 2 is the answer to the problem we just did, and I'm going to simplify it that way for here. Okay, so 30.0 grams of ammonium nitrate could react 20.5 grams of sodium phosphate, but we have 50 grams of sodium phosphate. So do we run out or do we have leftover? We have leftover sodium phosphate, and the answer to how much is, of course, how much we were given minus how much we actually used. So this is the 50 minus 20.5. What we end up with, and you'll see the final answer on the key, when we sig fig, leave it in whole raw numbers until the final step and then sig fig it, we have 29.5 grams of sodium phosphate left. Okay? I will print the sentence handout. I'll make copies for everybody, and I'm going to let you practice on these. I'm going to kind of float around. Problem. We've got calcium carbonate and iron 3 phosphate. reacting. We're given 100 grams of calcium carbonate and 45 grams of iron 3 phosphate, which is limiting. What mass of the excess is left over? So I'm sure that a lot of you started with your 100.0 grams of calcium carbonate. Yes? Okay, it's the first thing. It's easy. So if you start with that, you end up with, okay, so I think most of you probably got this. This is what you end up with, and you get, oh, okay, 100 grams of calcium carbonate can react 100.456, etc. grams of iron 3 phosphate. So if you wrote your sentence, you know that, well, we only have 45 grams of iron 3 phosphate, so we know immediately that iron 3 phosphate is going to run out. We don't have as much iron 3 phosphate as we could potentially react. So once we know what our limiting is, we start a factor label with our limiting. So we're going to take the amount that we were given of our limiting, which is 45.0 grams of iron 3 phosphate, and we're going to set up a factor label that's pretty much just like what we did, except we're now going from iron phosphate to calcium carbonate to see how much calcium carbonate we can react with the amount of iron 3 phosphate we've got. So that's going to look like this. It's going to look like this, and from that we get 44.79, etc. grams of calcium carbonate. So now we know that 45 grams of iron 3 phosphate can react this much calcium carbonate, but we've got 100 grams of the stuff. So what amount are we going to have left over? What we were given minus this. And you can rewrite your sentence a second time. Here's what that would look like. 45 grams of iron 3 phosphate could react 44.79, etc. grams of calcium carbonate, but we have 100 grams of calcium carbonate. So we will have some amount left over. And that amount, of course, will be our 100 minus our 44.8, etc. So we get, what, 55.2? Okay. So we'll have 55.2 grams of calcium carbonate left over. Does that help? Okay. I'll go ahead and let you keep going. The upshot is this. If you get lucky and your first factor label says, oh, this is your excess, you can subtract it and you automatically know your other one is limiting. If you're not so lucky and your first factor label shows you you're limiting, you have to do 2. So sometimes you can get away with doing only one factor label for a problem. Sometimes you have to do 2. But honestly, once you've gotten all your masses calculated, it's not a whole lot of work. It's just pretty mechanical, plugging it in and doing the math. So I'm going to float around and... Okay, so that's it. When we come in tomorrow, there will be question and answer, and then FIP, and then we move on.